Okay, so the last two videos we've been talking about work and power. It's time to talk about the third thing, which is also pretty directly related to work and power, although it also refers back to energy. All right, so this is called efficiency. The big thing with efficiency is it's a measure of the useful energy that is output by a system after it receives some sort of energy input. All right, so what do I mean by that? That's a physics definition there. Here's an example. All right, here we have wind turbines. This is a wind farm. It's probably located somewhere in the middle of the U.S. in farmland country. There's a lot of wind farms that look like this in that area because it's very flat and it's fairly windy. So this is a wind farm. There is a certain amount of wind energy that passes through these turbines, right? So the wind carries energy with it, all right, and the energy could be absorbed. Some of the energy can be absorbed by these turbines, right? So basically, if you find out how much energy is passing through the turbine's area, the area that's swept out by these blades, and then if you calculate how much electrical energy is produced by those turbines, that's how you get your efficiency, right? The amount of energy that passes through the turbines is the wind energy. That's the input energy. And then the output is the amount of electricity that these things generate. So we compare those two numbers and we can find out the efficiency of a wind turbine. Right. Another example of something that might have an efficiency rating would be this thing. You probably recognize that. That's an inline water heater. Okay? Some of you, or maybe most of you, have one of these in your house, and it makes your showers much more pleasant if you happen to like warm water, which I do. So I use one of these at my house pretty much all the time when I take a shower. So what does it do? Well, it takes electrical energy as the input, and it uses it to heat up water. So it takes electrical energy from the house electrical supply, converts it into heat, and uses that heat to warm up the water. So the input is the electricity that goes into this guy, and the output is how hot the water gets, right? How much energy is absorbed by the water and in the form of heat. So if we compare the input in electricity to the output of heat, then we can find out what is the efficiency of that guy. Dude, who knew that this could be so cool, right? Alright, so let's get into the nitty-gritty. What do we need to do to calculate efficiency? Well, we need to know two things. One, we need to know the amount of energy that's input to the system, and then two, we need to know the useful energy that is output by the system. Remember, energy is never lost, right? You can't destroy energy, but you can turn energy into forms that are not useful, okay? So, for example, with that water heater that we were showing earlier, the only useful energy that comes out from that water heater is the warmth of the water, okay? We don't care about anything else that happens inside, like heating up internal components or something like that. That is useless energy to us. All we care about is the energy that actually gets into the water, all right? And there will be some energy that doesn't make it into the water. So that's where we call it lost, quote, lost energy. It's not actually lost, it's just converted into forms that are not useful to us, okay? So efficiency is concerned with how much useful energy comes out at the end, okay? So if we write this as an equation, you're gonna have efficiency is equal to the useful energy output on the top divided by the total energy input on the bottom and multiplied by 100%. Now, in every single real-world situation, you will have less than 100% efficiency. There is always some energy that is converted into useless forms, okay? You never get out all of the energy that you put in real-world situations. You never get it all out. Sometimes we might assume that you get it all out because you get almost all of it, and it's just easier to assume that you get all of it for calculation purposes. But in reality, you'll never actually get all of of the energy as useful output. You might get 99%, you might get 95%. More often, you're going to get more like 70 or 60 or 50% efficiency. Okay, that's much more normal. All right. Again, here's a sample. So let's just take that water heater that we were looking at before, and we'll put some numbers to it. All right. So we say an inline water heater uses 1,000 joules of electrical energy input each second. All right, that would be a 1,000 watt heater. Then the water passing through the heater absorbs 450 joules of energy as heat each second. What is the efficiency? All right, let's zoom into this white space we've got right here. Remember, efficiency, I'll just do it as an E. Efficiency is total energy, useful energy output on top. So that's 450 joules in this example, divided by total energy input, and that was 1,000 joules each second. And then we multiply that by 100%. All right, and I will write this in red, the answer here. So 450 divided by 1,000, you're going to get 0.45. All right. 0.45, and then multiply that by 100%, gives us 45% efficiency. All right, so if this was a real example, you would have a heater that is 45% efficient at converting electrical energy into heat energy in your water. All right, that's really it. That's the basic idea of efficiency. You might have to do some things more complicated than this, but when it really comes down to it, that's it. All you need is the energy that's input. Sorry, the energy that is useful energy that is output. The energy that you put in, that's your input. Input here, output there. Multiply it by 100%. You'll always have less than 100%. If you end up with a number that's higher than 100%, you did something wrong. All right, you cannot have higher than 100% efficiency. All right, so that's a way you can check yourself to make sure you didn't mess up. Like, for example, if you put the output underneath the input, you'll end up with a number bigger than 100%, and you know you did it wrong. Okay? Awesome! Thanks for watching.